Hi everyone. So let's solve the following problem. So problem 23. It says prove that A divides B if and only if A squared divide B squared. So the forward direction is pretty straightforward. So if A divides B, that means there exists a C inside of the integers where when you multiply A by C, you get B. So if you squared both sides, you get A squared times C squared is equal to B squared. So if we set C squared is equal to K, which belongs to the integers, then C squared, then A squared times C squared is equal to A squared times K is equal to B squared. So, therefore, it follows that A squared divides B squared. So let's go in the reverse direction. So assume that A squared divides B squared. So what this means is that there exists a K belonging to the integers such that B squared is equal to A squared multiplied by K. So use prime factorization theorem to write A and B as products of primes. So write A as P1 R1, PK RK, and B P1 S1, PK SK. So from this, we get that A squared is equal to P1, 2 of R1 up to PK, 2 of RK, and similarly, B squared is P1, 2 of S1, PK, 2 of SK. So what we have is from the fact that B squared is equal to A squared times K. So then we could write that in terms of the primes. So we get P1, 2 times S1 times PK, 2 times SK, and that is equal to P1, 2 times R1, PK, 2 times RK multiplied by that integer K. So write K in terms of its prime factors. So K is equal to P1 U1 up to PK UK. So then we can write B squared as P1, 2 S1, PK, 2 SK, which is equal P1, 2 or 1, Pk, 2 or k, multiplied by P1, U1, all the way to Pk, Uk, which is equal to P1 to R1 plus U1 up to Pk to Rk plus Uk, and we must have that Ui, so Ui must be even. So as they add up, 2R1 plus U1 adds up to 2S1, etc. So then each of the Ui must be even, as 2R1 plus U1 adds up to 2S1, 2Ri plus Ui adds up to 2Si, so each of the Ui must be even. So from there, it follows that there exists a Q belong to Z such that Ui is 2. Let's use Qi here. So then we have that P1 to S1 up to Pk to Sk is equal to P1 to R1 plus 2Q1 multiplied by Pk to Rk plus 2Qk, and that is equal to P1 R1 plus Q1 Pk Rk plus Qk, all raised to the power of 2, is equal to P of 2S1 all the way to Pk 2Sk. So then we must have, raising the b to like the factors of the b to the power of 2, we can take the square root of both sides, and we get that b is a product of two integers, where one of the integers is a. So you have P1 to S1 Pk 2 of Sk, that's equal to P1 S1 Pk of Sk raised to the power of 2 is equal to P1 R1 plus Q1 multiplied by Pk Rk plus Qk squared. So then we have that P1 to the S1 up to Pk to the Sk is P1 R1 Pk to the Rk multiplied by P1 to Q1 Pk to Qk, which this is equal to b is equal to a multiplied by some z for z belonging to the integers. Yeah, I hope you guys enjoyed this proof, and I'll see you in the next video. Bye.